in chapter 1, we talk about multivariable functions. We talk about domain, range, and graphs of multivariable functions. Here, we first talk about the domain and range. Before that, let's know what is a multivariable function. Here, f of xy, as you see here, we have more than one independent variable in this function. F of xy, it means we have two independent variables, which are x and y. We have multivariable function. Here, x and y are both independent variables. As you see here, we have more than one independent variable. So that's why it's called multivariable functions. If you have more than one independent variable in any function, that means the function is a multivariable function. For the domain, is the set of all xy is the set of all xy which are defined in the function. I mean, which are defined for the function. It means if the function is defined at any xy values, we say the xy values are the domain. And the domain of functions of two variables is always a subset of R squared. Before, for the function of one variable, if we have f of x, the domain of this function is a subset, df is a subset of R. But for the function of two variables, if we have f of xy, then df is a subset of R squared. And if we have a function of three variables, if we have f of x, let's say y, z, then the domain of this function is a subset of R cubed. Okay? And so on for other functions. Here, we have an example. We have given the function of f of xy, which equals 3x squared square root of y minus 1. Here we should find f of 1 and 4 and f of 0 and 9. Here, as it's given, x is the first variable and y is the second. It means here, this is x and this is y. If the function is f of, let's say, yx, it means the first value is y and the second value is x. Okay? But here, the first value is x and the second value is y. To find f of 1 and 4 and also f of 0 and 9. And then you should find the domain of the function. The domain, as I said, is always a subset of R squared. For finding f of 1 and 4, f of 1 and 4, we just replace x by 1 and y by 4 in the function. And we get the result. We get the value. It equals. This is the function. We replace x by 1 and y by 4. We get 3 times 1 squared times square root of 4 minus 1. It equals 3 times 1 squared is 1. 3 times 1 is 3 times square root of 4 is 2 minus 1. 3 times 2 is 6 minus 1 is 5. So this is 5. F of 1 and 4 is 5. And for finding f of 0 and 9, f of 0 and 9, replace x by 0 and y by 9. It equals 3 times x squared, which is 3 times 0 squared, times square root of 9, minus 1 equals 3 times 0 squared is still 0 times square root of 9 is still 0. So you get 0 minus 1, which is minus 1. So the value is negative 1. The result. This is the result. Okay, so f of 0 and 9 is minus 1. And to find the domain, for the domain of this function, we just write down the condition on the variables. We don't need to write down the values. Okay, we just write down the condition on the variables. How to write down the domain of this function? We say the domain is a subset of R squared. That means since you have only two variables, two independent variables, so the domain is the set of all order pairs. Let's write down. We say f df, the domain, equals the set of all xy. Which xy? Which are in R2. What's the condition on x and y? We have no condition on x because x could be negative, could be 0, could be positive, because it's not in a square root and also it's not in the denominator. Okay, so we say such that y greater than or equal to 0. We have condition on in only y. Just we have condition on y values. We say y values must not be negative. Must not be negative. How about x? Since x is in the outside of the root, so it could be negative, it could be positive, it could be 0. That means we have no condition on x. We just have condition on y. What's the condition? We say y must be greater than or equal to 0. Okay? So this is the domain. We just write down like this. Okay? Okay. Here we say the domain for a multivariable function. For the domain, we just write down the condition on the variables. Here, since we deal with x as a polynomial, it could be all real numbers. So you have no condition on x. And for y is inside this square root. And y must be greater than 0, greater than or equal to 0. Can we give a negative value to y? No, because it will be undefined. That's why we say the condition is that y must be greater than or equal to 0. And all the other values are allowed. The answer is this. Yeah, this is the domain. I'm going to give you some more examples. Okay? Yes. How? How? I don't know. But you couldn't write down it as intervals. You cannot write down from negative infinity to infinity. This is for x. X belongs to this, and y to be greater than or equal like this. This is the formal way. Just write down like this. Yeah, it's correct, but you should write down also xy belongs to R squared. So it's long answer. Okay. So please just write down like this. It's okay. It's the shortest answer. So let's take some more examples. If we have f of xy to be the square root of fine domain of the following. Let me delete this. I'm going to give you some examples about finding domains. Find the domain for the following functions. First, f of xy to be the square root of x minus y plus 2. This is it's f of xy, not just f of x. The domain of this function, what we say, df is the set of all those order pairs xy belongs to R2. Always write down this. And then write down the condition. What's the condition? We say the terms inside the square root must be greater than or equal to 0. We say x minus y plus 2 must greater than or equal to 0. That's all. Okay, we just write down the condition. That's all. And let's take another example. We say f of xy to be x plus y. Yes. It's enough. That's all.
Like x minus y plus 2. We can do it a little way.
How? You even can write down as x must be greater than or equal to y minus 2. It's the same.
But like we can say minus y plus 2 should be bigger than 2.
My x minus y should be bigger than or equal to negative 2.
Just minus y is bigger than 2.
Yeah.
X should be like
we can also say that y is less than or equal to x plus 2. That's all could be obtained from this. It's only moving the variables from one side to the other side. All are allowed, all are correct. Okay? You even can write down like this. These all could be obtained from this. Any of these forms are true. Okay? So here, for this example, and the example is, let's say x plus y over x squared plus y squared. What's the domain of this function? We say, since you have two variables, so the domain is the set of all pairs in R squared such that, what's the condition on this? We say the denominator must not be 0. Which time the denominator is 0? If x and y are both 0. If both are 0, then the denominator is 0. In only one case we get 0 here. Since both are squared, if you give any positive value or any negative value to x and y, even if one of them is 0, it's okay. But not both are 0. Both must not be 0. What's the condition? The condition is that x except where x doesn't equal to y equal to, let me write down it in another way, except while xy doesn't equal to 0, 0. That's the condition on it. If both are 0, then the denominator is 0. In all the other case, it's not 0. That's all. This is the domain of this function. Let me write down another example. If f of xy to be 1 of x plus y. How about this one? Yes. Yes, it must not be equal to this one. Yeah, thanks. We say f of xy equals 1 over x plus y. How about the domain of this function? We say the domain is the set of all pairs in R squared such that x plus y doesn't equal to 0. In this case, we say x plus y doesn't equal to 0. But in the above one, we know that in only one case, x squared plus y squared is 0. If both are 0. Okay, but here we also can say x doesn't equal to minus y, or y doesn't equal to minus x. All of these are correct. Okay, just write one of them. Let's see. Yes, you can say that. Yeah, x squared plus y. Even here, you can say x squared plus y squared doesn't equal to 0. It's the same, yeah. In only one case, this doesn't equal to 0. Okay, if both are not 0. In only one case, this equals to 0. If both are 0. That's it. And another example, we have f of xy to be the logarithm of x minus y squared. For this one, what's the domain? We say the domain of the function is the set of all pairs in R squared such that we say the angle of logarithmic function must be positive, must only greater than 0. We say x minus y squared greater than 0, or we can say x greater than y squared. That's all. Is that easy? So that's all about domain of multivariable. Sorry, function domain. The second one, yeah. Here we cannot cancel out numerator and denominator because in the denominator we have sum of two squares. It couldn't be factorized. So you just leave it like this. For the domain, we say the domain is the set of all pairs in R squared such that the denominator is not 0. We say x squared plus y squared must not be 0. In which case, these two are 0. X squared plus y squared is 0. If both are 0, then we get 0. Okay? We say if x equals y equals 0, then x squared plus y squared is 0. In only this case, we get 0 for x squared plus y squared. That means we just exclude this value from the domain. We just exclude the zeros of the denominator from the domain. So the excluded values of x and y are 0, 0, is 0, 0. We have only one point which is not including the domain, which is 0, 0. Is that clear? You can either write down that or this one. So let's take another example. Let's say f of xy to be the square root of x plus y of y. This one. What's the domain of this function? Shouldn't be 0. Y shouldn't be 0. That's condition on y. How about the numerator? In the numerator, we have a square roots. We say the terms in the square root must always be greater or equal to 0. That means we say the domain here, the conditions are x plus y must greater than or equal to 0, and y must not be 0. Okay, must not be. These are the conditions on the variables for this function. So the domain, say df equals xy in R2, such that we just write down both conditions. X plus y must greater than or equal to 0, and y must not be 0. This is the domain. Okay, that's so easy. It's actually easier than finding domain of one variable function.
You say that y cannot be equal to 0 and x should be positive.
X, or how about y?
But also we have y in both, like we did later, like we have it in both sides.
Here we have two conditions on y. One is with x and the other one alone.
Also, we should go ahead and like have y is equal to 1. So we both are 1, right?
Yeah.
Both of them are so both y cannot be equal to
Sorry.
0 and x should be
Oh, you confused. These two cannot be cancelled out. Okay, these two cannot be cancelled out. For example, we said y must not be 0. That's the condition 1. And you say x should be positive. That's the conditions. You said that y must not be 0 and x must be greater than or equal to 0.
Yeah, or we can say y should be bigger than 0 every time.
Bigger than 0. But I'm gonna give a value for this function which is defined, and y is less than 0. Okay, let's check. If x, let's say it's minus 5, y equals minus 2. Check this.
We can't have y because it equals minus 2. We should have positive y every time.
You said we should write, look, this is in the domain. It's allowed. Why did you exclude it from the domain?
Because we have a loose curve up.
Look, ليه أم خالقها معنا لدومينا هي. It's defined, but with your conditions, it's excluded. So this is not the domain. This is the correct one. We say x plus y must be greater than or equal to 0, and y must not be 0. Or we can say, so that's all. Here, y, let's take a point. Y to be -2, x to be, let's say, 4. Okay. Is this defined in the function? Yes, it's defined. But in the conditions that you said y must be greater than 0. You excluded this from the domain. That's why it's not correct. Yours is not correct. So the domain is that x plus y is greater than 0, greater than or equal to 0, and y must not be 0. Y must not be 0. That's all. So here we took 5 extra examples about the domain. Now we have sketching the natural domain. Here we should sketch graph of the domain. For this example, we should first find the domain, then sketching its graph. We should sketch its graph. The function is ln of x squared minus y. This is the function. To sketch the graph of this domain, of this function, first we should find the domain. We should find the domain first. For the domain, we said the angle of logarithmic function, ln is also a logarithmic function. It must be greater than 0. It must be greater than 0. That means x squared minus y must be greater than 0. That means x squared is greater than y. This is the condition on x and y. So you say the domain is the set of all pairs in R squared. Since we have two variables, that's why we say R squared. If you have three variables, we say in R cubed. Such that x squared is greater than y. This is the domain. And now to sketch the domain, to sketch this domain, what should we do? We say x squared is greater than y. We just change this inequality to equality. We just change it to equality. Okay? It becomes equality. What's the graph of x squared equals y, or y equals x squared? We are gonna draw the graph of it. The graph of y equals x squared is this. This is y equals x squared. So now, we said that x squared must be greater than y. X squared must be greater than y. It's either here or there. Let me check. Change the. It's either here or here. The domain is either here or here. Let's check. Okay. Let's check. Let's pick a point here or here. Okay. Here or here. Let's pick a point. Give a point in one of those two areas. Let's pick a point here. What's this point? Let's say -2, 0 and -2. 0 and -2. And we return to the inequality. If it satisfies the inequality, it means here is the domain. If it doesn't satisfy, it means here is the domain. Okay, let's check. Zero and -2. We replace x by 0 and y by -2. We replace x by 0 and y by -2. In y, in x squared is greater than y. If we replace x by 0, we get 0 is greater than -2. Is it correct? Yes. That means this is the domain here. It's all. Okay? All of this area is the domain. Or let's pick a point in the other side. Let's pick a point here. Let's say this one. It is 0 and 2. If it satisfies, it means here is the domain. If not, it's the other side. It's the domain. So here we test 0 and 2. We replace x by 0 and y by 2. Is this correct? No, it's not. That means here is not the domain. So the domain here is this area. Where? Just do this, that's all. It says sketch the domain. So the domain is that red area. Okay? This is the domain. You even don't need to write down these. It's for just finding it. Yes. Sorry. We have another example. It's about finding domain and range of this function. For this function, we should find domain and range. Range is always a subset of R, even if you have 2, 3, or more independent variables. Range is always a subset of R, but the domain, it depends on the number of independent variables. If you have only one variable, it's a subset of R. If you have two variables, it's a subset of R2, and for 3 variables, it's a subset of R3, and so on. Here we have given this function. In the function, we have only 2 independent variables. That means its domain is a subset of R2, and its range is a subset of R. For the domain of this function, we say the domain is, what's the condition on xy here? We say x times y must not be 0. X times y must not be 0. That means none of x and y to be 0. We say the domain is the set of all pairs in R2 such that xy means x times y doesn't equal to 0. This is the domain. And for the range, we say by replacing x and y by the points in the domain, what we get will be the range. Here in this function, as we have no x in the numerator, that means we don't get 0. We don't get 0, but we get all positive and negative values. We get all negative values, we get all positive values, but here we only don't get 0 here. We don't get 0 because in the numerator it's always a constant. That's why we don't get 0. So the range is the set of all real numbers except 0, or from negative infinity to 0. 0 is excluded, union 0 to positive infinity. This is the range. This is the range for that function. Range is always a subset of R, even if we have 2 or more independent variables. Now we take some examples. Find domain and sketch its graph. The graph, sketch the domain. For these functions, I'm going to give some functions. First, if f of xy to be the square root of x squared plus y squared, let's say -4. We have given this function. First, we should find the domain. We should find the domain. What's the domain of this function? We say the terms in the square root must greater than or equal to 0. Must greater than or equal to 0. That means x squared plus y squared -4 must greater than or equal to 0. Or we can say x squared plus y squared must greater than or equal to 4. This is the condition on the x and y variables. So the domain is the set of all pairs in R2 such that x squared plus y squared greater than or equal to 4. This is the domain. To sketch the domain, we are going to change this inequality to equality. We say x squared plus y squared equals 4. This equation of a circle. This is radius squared. This is r squared, which is the radius squared. So the radius here is 2. The radius here is 2, and its graph is from 2. This is 2, this is -2, this is -2. This is the graph of this circle. The center is 0, 0, and the radius is 2. This is the graph of this function. And we say x squared plus y squared must greater than or equal to 4. It must greater than or equal 4. The condition is this. Here we have this circle. It's either outside or inside of the circle. Okay, let's pick a point inside the circle. Here, let's pick this point. This point is 0, 0. This point is 0, 0. Here, this is 0, 0. If we test this point 0, 0, we replace x by 0 and y by 0 here. We get 0 squared plus 0 squared is greater than or equal to 4. So 0 is greater than or equal to 4. Is this true? No, it's not true. That means inside of the circle is not in the domain. So outside is the domain. Even the circumference of the circle is also in the domain. This area is the domain. So the domain is the circumference of the circle and outside also. This is sketching of the domain for that function. راس مكان ليرة إما شيء معناها x دوجا زائد y دوجا قولت لي إنسانة بتشوار إما يمكن بإكسانة جاي أما كها معناها هالكشي بازنين شقي بازنك 0 0 چونکە x دوجا y دوجا چی لەگەڵ نییە نەماوەتەوە x ناقص ژمارەیەک دوجا یان y ناقص ژمارەیە یا زای ژمارەیەک دوجا کەواتە سنتەر 0 0 نیوەتیرەکەی چەندەیە ئەمە نیوەتیرە دوجایە نیوەتیرەکەی چەندەیە 2 یەکەیە نیوەتیرەکەی 2 یەکەیە کەواتە لە 0 0 و 2 یەکە بە دەوری خۆیان وێنەکەی کێشی ئەم وێنەکەمان کێشە ئەنجام زای ناو وێنەکە دۆمینەکە یان دەرەوەی وێنەکە دۆمینەکەی خاڵێک وەرەگرین لە دەرەوە یان لە ناو کێشە نی با لە دەرەوە خاڵەوەی با بڵێ ئەم پۆینتە ئەمە چییە 4 و 0 باشە 4 و 0 ماوەگیر لە دەرەوەی بازنەکە وەرمان گرتووە دین لە ناو ئینیکواڵتیەکە دانێنم زای پاسەدان ئینیکواڵتیەکە یان ئەگە پاسەدانی کرد کەواتە دەرەوەی ئەگە پاسەدانی نەکرد کەواتە ناو کەواتە ئەگەر 4 و 0 تێست بکەین x 4 y 0 بابێن دانێنەوە ئەڵێن 4 دووجا زای 0 دووجا ئایا گەورەترین یەکسانە بە 4 ئەمەکە 16 ئایا گەورەترین یەکسانە بە 4 بەڵێ ڕاستە so it's outside.
How I know that this equation is equal to circle?
You should know that.
Oh, I should memorize it.
You studied this before.
I know. I forgot. So there's any way to know it?
No, it's only recognizing the equation. You should know. If you have x plus minus something squared plus y plus minus something squared equals to a number. That's equation of a circle. Okay? The general form of equation of a circle, we say x minus h squared plus y minus k squared equals r squared. This is general form of equation of a circle. Here, we say h and k is the center. R is the radius. Okay, but in this example, h is 0 and k is 0 also. That means the center is 0, 0, and r is 2. 0 and 2? 0 and 2 is equal. It's equal, yes, it's true also. As I said, وكوتم تشوي بازنكا ودروش. هموي لبريك سالي لقلايا. As you see, here we have equality. We have equality. That means its circumference and outside is satisfies. Okay, outside and circumference are both in the domain. Okay. So that's how we sketch graph of domain for a function. And let's take another example to be inside of the circle as the domain. Okay, I'm going to take another example. If f of xy, the second one, f of xy to be the square root of minus x squared minus y squared plus 4, let's say plus 9. To find the domain of this function, we say x squared minus x squared minus y squared plus 9 must be greater than or equal to 0. Okay, and here we say x squared plus y squared must less than or equal to 9. Okay, so the domain df is the set of all pairs in R2 such that x squared plus y squared is less than or equal to 9. This is the domain. To sketch the domain, we just gonna change this inequality to equality. We get x squared plus y squared is less than, so is equal to 9. This is the equation. This equation is equation of a circle. It's equation of a circle. Now, we say equation of this circle, we should first draw the graph. This is 3. As you see, the radius squared is 9. So the radius is 3 and the center is 0, 0, 0. It's 3, it's 3, it's minus 3 and minus 3. Now we test a point. We pick a point either inside or outside of the circle. Let's pick a point here, 0, 0. If we replace x and y by 0 in the inequality, not in the for the equality. For the inequality is 0 squared plus 0 squared less than or equal to 9. Is 0 less than or equal to 9? Yes, it's true. That means inside of the circle and also the circumference, since you have equality, the circumference and inside of the circle is the domain. Yes. Look, 2 squared plus 2 squared, is this less than or equal to 9? It's 8. Yes, it's true. All of these points satisfy the inequality. That's why we say the domain is inside of the circle. 3 and what? 3 and 3, it's not inside of the equality, inside of the circle. Look, 3 and 3. We say 3 squared plus 3 squared. Is this less than or equal to 9? That's 18. No. And 3, 3, as you see, 3, 3 is somewhere here. It's not inside of the circle.
Same number or x and y should be the same number?
No, it's okay. You can pick another point. Let's say
x2 and y is
1. X2 and y is 3. X is 2
so 4 plus
and 3. 4 plus 9. It's not included. Yeah.
we say 2 and 1.
Yeah, it's included. Yeah. Look, 3 and 2. 3 and 2 is somewhere here. 2 and 3. Sorry, 2 and 3 is somewhere here. It's not inside of the circle. The most important thing is that if you know the point that you take is inside of the circle or outside of the circle. That's all. If it's inside and it satisfies the inequality, it means inside of the circle or the inside of the circle is the domain. You just need to sketch the domain. You don't need to test all points. Just pick one point. Okay. So let's take another example. If the center of the circle is not 0, 0. Okay. I'm gonna take another example. Okay, so let f of xy is 3. F of xy to be the square root of x squared plus y squared minus 2y minus 3. Okay, if we have this example, first we should write down the domain. We say the domain is x squared plus y squared minus 2y minus 3 must be greater than or equal to 0. Okay, first let's simplify this more. We have x squared plus y squared minus 2y minus 3 is greater than or equal to 0. Here, these two, x squared minus 2y, could be perfect square. We complete the square. Okay, how to complete the square? We have x squared plus y squared minus 2y. What we do? We divide the coefficient of y by 2. We divide the coefficient of y by 2. And then we square it. 2 dividing by 2 is 1. Then squaring it is still 1. We add and subtract this number to the equation. We add and subtract that number to the inequality. Okay? These three numbers, these three terms together, we have x squared, and these three terms together become y minus 1 squared. Is it? It's completing square. Do you know that? Okay. And here we have minus 1 minus 3, which is minus 4, is greater than or equal to 0. So here we say x squared plus y minus 1 squared greater than or equal to 4. This is the simplest form. So you say the domain is xy in R2 such that x squared plus y minus 1 squared greater than or equal to 4. Okay, this is the domain. Now we sketch the domain. How to sketch the domain? We are going to sketch the graph of this circle. It's equation of a circle. Let me clean this. Now we try to sketch the domain. For sketching the domain of this function, we have x squared plus y minus 1 squared. We just change the inequality to equality, equals 4. This is equation of a circle, and its center is 0 and 1. This is center. Radius is 2. So from this point, we are gonna draw the circle. This is graph of a circle. Here, the center is 0 and 1. This point is the center. And from this point, we just count 2 points, 2 units for all sides, and then we sketch the graph. Here, look, the general form of equation of a circle is x minus h squared, yeah, plus y minus k squared equals r squared. See, here, h and k is the center. Okay? We say 0 and 1 is the center. And from this point, we are going to count 2 units for all sides, then we sketch the graph. From this point, if we count 2 units to down, we get here. And if we count 2 units to up, we get this is 3, that's 4. And so the graph is like this. This is graph of the circle. This is graph of the circle. And now we test a point. We test a point. We pick a point to be inside or outside of the circle. We can pick the center. We can pick any other point here. Let's say this point. Okay, or let's say 4 and 4. It's not inside of the circle. Let's pick 4 and 4, 3 and 4. Okay, let's say 3 and 4. It's not inside of the circle. If you put this to the equation, to the inequality, what we get? We get x squared, which is 9, plus y minus 1 squared, which is 4 minus 1 is 3. Squared is 9. Is this greater than or equal to 4? Yes, it's true. That means outside is the domain. We pick a point. We picked a point from outside, and it satisfies the inequality. That means outside of the circle is the domain. Okay, inside is not the domain. Let's pick a point inside of the circle. Let's say 0, 0. If we replace x and y by 0, 0 here, we must get a negative value, because we said inside is not in the domain. If you replace x by 0 and y by 0, here these all are 0. What we get? We get the square root of -3, which is undefined. So it's not in the domain. All the domain points must be defined in the function. So the function must be defined at all the points of the domain. If we pick any point outside of the circle, the function is defined. That's it. Okay. Now, central circle ka lera ali ama general formi halka şey circle bazne ali h k center ay lera chime x صفر لقلا بوين نساو y چی لقلا يكي لقلا كاته h صفر k يكا. If this was positive, that means k is -1. Okay, so that negative sign is for the rule. أو ناقص إياه ساكية. أجر هاتو مجبر بناقص ورقة. أجر ناقص ومجبر. Okay. Okay, it's enough for today. So if you have any question about today's lecture,